Okay, hi everyone. Morning. Have a show of hand. I want to have a question on how many of you uses incremental materialization in your DBT model? Oh, that's really more than what I expected. Because I think every one of us who are DBT practitioner, we start off with table. And it kind of stick with us, it's accurate, it's always fresh, but until a point it doesn't work. It just doesn't make sense anymore. Yeah. So today I'm going to talk about something which is how over at Delivery Hero, we face a problem of trying to balance between cost as well as providing accurate data for our data consumer. And what are the steps that we take to mitigate this, or at least we try to. So a little bit about myself. My name is Bernard. I'm from Delivery Hero, a senior analytics engineer there. And in today, I'm going to walk you through very quickly on some of these points, a dilemma that we often face in the organization, which is how do I provide accurate, fresh data to my data consumer? On the other hand, as engineer, how do I keep my costs low? Okay, one thing is we just can't keep costs going up unless we are flush. Yeah, and a problem we face with our initial approach, which is a kind of a more one-size-fits-all. And I should say, in this case, we found out it's one-size-fits-none. And how did we approach to kind of solution something out, which eventually we came out with a triple mode incremental model macro. Okay, that I'll show over so that you get a better idea. And what does this brings to the business in terms of impact and some of the learnings. So a little bit about the brand, Delivery Hero. We are actually a food delivery company with multiple brands spread across the world. And from where I am, we have internally this Pandora platform that covers 3 brands that operate in Asia, Europe, and Turkey. So as a data organization, we are supporting just these 3 brands itself across 17 markets. So over at Delivery Hero, we don't just see DBT model as DBT model itself. It's just not a means to an end. We see them as a data model. Firstly, what this means, we see them as a knowledge base where we consolidate business logic to prevent silos, and we apply business logic, centralize them, formalize them for long-term maintainability. Okay? And over time with that, this becomes an organizational asset where all the DBT model actually have a value to the business. It matters to them. And all these things are put through clear schema and with clear expectation on when those tables will be updated. So I'm going to spend a little bit of time here, a dilemma that I kind of face. How do I design and implement a data product that my stakeholder would love? But then again, let's be honest, no one would love. They will just, or at least hate us less. That's all, okay? So on the top right, what I'll see is that me as an engineer, okay, how do I make my data user hate me less? I have lowered the bar since then from loving to hate me less. I want to have a longer look back window so that if there's any late incoming data come, I will be able to still capture them. Okay, so that I don't miss them totally. But the problem with that is that I have to trade off with a slower runtime and a more expensive compute. And on the other hand, on the bottom left and right, the bottom left, first I have my business user who would always demand, the business always move faster than the data organization. They will say, I want this. We have new logic added in. How can you bring those into the table? Okay, so that I don't want to miss the opportunity to make a decision now there. And on the other side, I have my data analysts who are much more data informed. Okay, they will say that I understand there's a logic change in the business, we'll need to apply it, but how long does it take for you to bring it up to date? Let's say if we want to backfill from the start of this year, okay? And for them, time to insight as an analyst matters. That's where their value is. They want to deliver insight fast to their business stakeholder. So there's always, you can kind of see where this dilemma is already. I have my cost to manage, I have a time, and the other side, I have people who are demanding faster time. So how can we build a model that are both highly accurate and efficient? This becomes the theme for what we'll be talking today. So before I move in, I want to show you our initial Airflow project, okay? How our initial approach, where first, we want to take a single one-size-fits-all strategy, okay? It kind of works for us initially. We'll have a 92-day look-back window so that every day when my schedule runs, I always look back 92 days such that any late incoming data doesn't get missed out. So that's fine, it works. But the downside is that it's powerful, but then it's slow. Problem comes in if we are going to do a backfill. Okay, so as you can see the green bar below, at any point in time, this is likely what we'll be seeing in our schedule flow itself. You have tasks that's running a backfill, way back, but also scanning a 92-day window look back. Okay, and it move on to the other day and the other day and the other day. The problem is that I think if it's over a certain period of time, data is not expected to change much. They are probably fixed. But doing a 92-day look back kind of just wasting resource. It's just not efficient. So we can always adjust it, but then again, this brings a problem is that I have to raise a PR to change my look back date in order for it to run. So over time, we will need to look into this problem on how can we approach this differently. Obviously, as our organization grow, more data user comes into the picture, this way of working doesn't really work. So we took on from a product perspective. Let's stem from a product manager. How should I then approach it? What's my user pain point and what's our engineer pain point? And with that, we came up with 3 scenarios, okay, from the common requests that we see. And as engineers, the experience we have, we see them first. I have my daily schedule query that is working fine right now. It works to give me a 92-day look back in any case if there is late incoming data. So this is, I think we can keep with that. When there is a backfill, such as a logic change being added, and the stakeholder, even though they have no immediate need for those data, as engineers, we want to bring those data in so that we maintain a record. And all these things, if it's way into the history, perhaps I don't need to do a full 92-day scan. I will just do a 1-day scan instead, just to bring it up to date. Okay, it works. And also lastly, in certain cases where the model are kind of relatively smaller, compute lighter, we can actually do a bulk backfill. Start a 3 years back and we'll do a 3-year load one shot. Okay, it's going to be heavier, but over time, later on you will see that sometimes it is heavier, but incrementally, it is going to cost lesser compared to an incremental model. So with that, we came to this solution of a smarter way of doing things. How about we have a triple mode incremental model? Okay, what if we have a DBT model that is more context aware? So in order for that to happen, we have to abandon the one-size-fits-all. We want to make the DBT model context aware such that in this case, it behaves differently between a daily run versus a backfill. So we were working together with the engineering team and we kind of say, hey, you know, perhaps we can come up with a macro of is backfill that looks into the Airflow deck to understand that, hey, this is an Airflow configuration for backfill. Why not as a switch? And then if it's a full refresh, that's a second switch. And with that, we want to aim for 3 modes, which is a production mode that looks back 92 days on the daily level, a backfill that's much more efficient, only looking back 1 day in the very past history, and a full refresh mode. We want to have something that we can toggle between these 3 different modes. So over here, eventually this is what is the DBT macro that we we wrote up. So in the first half, the top half section of things, is that you can see, let's look at the top half here, okay, which is here. First, it looks if there is a backfill job, if this is a backfill job or not. And if it is, let's adjust my window to only 1 day. Just do it 1 day. If not, else, we would then generate an array of dates for our incremental. So these are typically defined in our end days on the top here. Yep. So this is how we do it. So it generates an array. If let's say we are looking at 92 days, so it will be an array of 92 days into the past. So I think for those of you who are familiar with DBT, writing DBT macro, I think this should be relatively easy. But more importantly is that, you know, the macro is just a macro. I want to move on to the next slide where I'm going to tell you how does it work in application. So on the top part, top one-third, what you will see is actually a DBT configuration, something that you are very familiar with if you are working incremental model. So this is where we will set up. In this case, it will be an insert override incremental model. And on the second chunk, just for readability and simple, it's optional. You can choose to always embed it as part of your SQL query. But what we did is that we create one parameter, a date parameter section for it, such that if it is an incremental model, it will run, look back at past 92 days. And if not, if it's a backfill, it will be a single day. So all these are together all in one itself. And lastly, that will be the bulk backfill mode that I talk about, which it looks, in this case, a last 3 year. So it defines, as of right now, I'm only adjusting my start date. I'm not adjusting my end date. My end date will always be fixed. And then later on, we have the last section, which is where your SQL query will be written. And in there, you can see that it always references start date. The parameter will adjust what is the value that goes into this start date itself. So once we implemented this, we decided to do a quick test, a test on a smaller sample size, and did some extrapolation of cost. If you do a 92 days look back on, which is our initial mode, it takes about 2 minutes to run on our Google BigQuery. Okay, and the slot consumed is 6 hours. For those of you who are on BigQuery, you will be understanding that basically everything is charged based on slot consumed. That matters. Less so on the runtime, but on the slots. And in this case, it translates to about 8 cents euro. If I'm going to extrapolate it to a 3 year, I am going to do a backfill for 3 years. Okay, and in this case, I'll be looking at a 43.6 hour run. Okay, which roughly takes about 1.8 days for it to complete. It will consume over 7,000 hours of BQ slots, and which adds up in terms of cost, is going to cost out about 100 euro, thereabout. However, with this macro, it understands that it is going to do a full load, and it runs a full refresh for 3 years. It will take slightly longer, a 2.4 minutes for it to run, 2 minutes and 40 seconds, sorry. Yeah, for it to run and it consumes by itself, compared to one-to-one comparison, it may seem that it's a lot more, but if you're going to look at the same period of data that it's trying to fulfill, it will be a lot of savings down there. So looking back, what we see and what we learn from this is that abstracting environmental logic into DBT macro is actually a powerful pattern. Okay, you really need to start off with what do we want to achieve here, and then how do we then make the tool kind of work for us. And as a starters, we always start off with a one-size-fits-all, but over time, your needs may change, organization requirement may change as well. So this method may not work every time. And this pattern really, for us, it helps solve the problem that we have before DBT had a native solution in it. So I know in recent DBT release, they came out with macro batch. It's something that we're going to look at next to see, does it work? Because if it's working, maybe it's something that we can adopt and shift away from our custom macro. But as of then, if not, the custom macro still works for us. Okay, so this is what I have to share for today. So I'm going to give it back the time for any Q&A. But other than that, thank you for listening in.